As you can see, we are currently in the break of Bluebook exam number 10 before we go into the first math module. Now, the 10-minute break is always going to come between the second reading and writing section and the first math section, both in your practice exams and on test day. But you can choose to just go ahead and resume testing, but be aware that as soon as you do, you're going to start the timer on the math section. And you'll note as we come in here and you see this introductory information that we've got a little bit more time than usual, and that's because we've selected time and a half accommodations for this exam, just so that we've got more time to explain the questions as opposed to just rushing through to complete in the normal pacing. Now, that said, you will be able to go through this section in appropriate time, but the skill that the math side of the SAT is going to reward most is flexibility and approach. So for some of these questions, we're actually going to end up seeing more than one way to do it. So you can see just the introductory information and explanations on how you're going to insert or enter the numeric entry questions. So we'll just hit close on this for now. And we've got our very first question. And you probably will want to just have your calculator up. And I do generally recommend just using the provided calculator for this exam, unless you really like your own personal one. And of course, to illustrate in the video, we're going to need to have this Desmos calculator up. Also, if you forget any sort of formula, you can click on this reference thing and you'll see all of the details you'll need for geometry. So we'll just close that back up for right now. And when we are engaging with the math section, you will have scratch paper. And what's on the right of the screen is going to illustrate how you're going to want to engage that scratch paper. But for this exam, especially considering the timing aspect of it, very often you're going to want to ignore that scratch paper. So we're going to actually engage the interface a little bit more. We're going to highlight what we're being asked to deal with and potentially avoid dealing with the problems on our scratch paper. So to begin every problem, including number 1 here, we're just going to highlight what we're being asked to do. And we want to figure out the probability of selecting a bead that has a defect. We can see up top, for a particular machine that produces beads, 29 out of every 100 beads it produces have a defect. Okay, our answer is 29 out of 100 then. Don't overcomplicate things. These earlier questions tend to be easier than the later ones, so don't waste time unnecessarily. You should know that probability is just desired out of possible, and choice C matches that without really doing any math at all, just understanding the concept of probability. Number 2 here, we're being asked for the speed in miles per hour of the car 5 seconds after it began to accelerate. So this is how I could use the calculator. Have it right here. We've got the equation that gives the speed s in miles per hour of a certain car t seconds after it began to accelerate. Well, we know that t is being told as 5. So 5 times 3 gives me 15. And we're going to just then x out. We'll do 15 plus 40 gives us our 55. Well, I already saw it. I didn't even have to hit the enter. And we could select 55, knowing that that's the correct answer. Didn't even have to get outside of that given calculator. We'll move to next. Now, this question here. We've got 4x equals 3. What is the value of 24x? I don't want to waste time solving for x individually. I can see, how do I get from 4 to 24? Well, I just multiply by 6. So I come back over to the calculator. We have our 3. We multiply that by 6. We discover that the answer is 18, and I'm done. And I don't want to unnecessarily solve for undesired individual variables, and I can just make this a really fast question. Then we've got number 4, which gives us a graph, and we're being asked for the line of best fit. I'm just going to highlight that. I'm going to scroll down here, and maybe I'm just feeling that the calculator's a little bit too much on the screen. Just scroll down, don't scroll up and down. Scrolling up and down is very disorienting. I don't want to do it at all, and I'm just going to eliminate using our elimination tool here on the right-hand side. If you don't see your elimination tool, you can come up here to scroll, and you can select that, cross out the choices. You always want to have that cross out the choices thing selected. And you probably should have it selected from your work on the earlier modules, but just in case it isn't, you come up here, scroll up, you'll select that ABC with a slash through. So I just have to trust the figure as drawn to scale, and we're looking for what represents the line of best fit again. And we should be able to see that our y-intercept is going to be positive 3.4. So we can eliminate anything that has a y-intercept of negative 3.4. Similarly, we can see our slope is positive, so we can eliminate the one that has a negative slope there of choice C. And our correct answer is A, and we just move on to the next question. Here we have 300,000 paper clips is our total, and actually I should have skipped to the end. We're looking for the percentage of the paper clips that are size large. So this is where, could I use the calculator? Sure. Do I have to? Probably not. Because looking at this, we've got 300,000 paper clips and 234,000 that are size large. The way that most people are going to engage with this is by going, okay, let's divide 234,000 by 300,000 using the calculator. Is that going to get you the correct answer? Absolutely. Is it unnecessary? Absolutely. Because I should be able to do some logical estimation just looking at the answer choices here. Well, clearly, the majority are large. So goodbye A, goodbye B. I should know what 66% of 300,000 is going to be. It's 200,000. Well, that's not going to work because we've got over 200,000. Our correct answer is going to be D without even having to pull out the calculator. If you're not confident in this, pull out the calculator. You'll do, instead of doing all the zeros, which is just going to take more time, you could just do 234 and divide by 300, knowing that the zeros are going to cancel out. And there, of course, is your 78%. Couple of different approaches. Like we said at the beginning of this video, you want to maximize efficiency, you want to be flexible, think about logical estimation to avoid unnecessary calculation. Then our next question, we're being asked for the relationship between x and y. We can see that we've got a linear relationship, and we can see that from the chart probably. We do see it as we read through as well, but I should be able to determine first what our y-intercept is. That's when x is 0, and that's going to be 18, so we can eliminate the answer choices that do not have plus 18. Then, once more, I don't need to fully calculate this. I don't need to write out the slope-intercept form of a line. I don't want to waste time doing that. I should be able to see, well, as x goes up, y goes down. This says that as x goes up, y goes up. B is out. Our correct answer is D. And again, logical evaluation. Don't waste time actually solving, and we can hit next. Here we've got our little keypad that shows up for the interface when you've got a numeric entry question. Again, you've got all of the explanations about the numeric entries. The biggest thing is don't enter a mixed number. You have to do a improper fraction. Instead, don't enter symbols. So we just got to follow the rules here. You'll know the rules by this point, hopefully in your own practice. But if this is your first engagement with a practice exam, just read this on your own. It's at the beginning. You can read it anywhere. But for the purposes of this question, we can see we've got a function f, and it's defined by this structure. Again, if I don't have to engage my scratchpad, I'm not going to engage my scratchpad. You can see that the calculator, even if you close it, saves the last question, so that's kind of nice. But I'm just going to do my math in the calculator. So 2 squared is 4, plus 2 is 6, plus 71 is 77. So now I come to the keypad, 77, and we're done. Hide the keypad. Next. Simple enough. Don't want to waste time, again, working through it in full on our scratchpad. It's right there. Now, here we're being asked for which is equivalent to this structure, where m, q, and z are positive. Now, you just want to do one thing at a time. And I don't need to process everything. I just look at my answer choices after completing a step. And we should recognize that the way you combine exponents when multiplying, and that's ultimately what you're doing with these two bracketed parentheses, we're just multiplying the exponents, or multiplying the bases and combining the exponents. Just pick the m. We'll start with m. M to the 4th times m means we're going to have m to the 5th. I should be able to track that mentally. I don't need to write it down anywhere. I look at my answer choices now, looking for m to the 5th. M to the 4th is not m to the 5th. M to the 5th is m to the 5th. M to the 6th is not m to the 5th. M to the 20th is not m to the 5th. I don't even really care about the other ones, but if we track q to the 4th times q to the 5th, we're going to add those exponents, q to the 9th, z to the negative 1st times z to the 3rd is going to become z to the 2nd because we add those exponents. Of course, when you add a negative, you're subtracting. You can see how b is the correct answer. And again, we could have gotten there without really doing really anything with the q's and the z's. Always look at your answer choices after completing a step and see whether or not you need to do anything else. Just want to make sure I didn't double click. But number 9 here, Again, another instance where we can maximize our efficiency. So we are being asked for the length of xy, and I'm going to actually engage the scratch pad here just so that I can show how to do this without actually drawing anything, because I don't want to draw unless it's absolutely necessary on this exam. It's just not efficient. So triangle ABC is similar to triangle XYZ, where ABC correspond to X, Y, and Z. So we know that A is equal to X. We know that B is equal to Y. And we know that this is all just similar. So there's going to be a constant proportion. And C is equal to Z. And we're told that the length of AB is going to be equal to 170. And we're told that BC's length is equal to 850. And then we know that we're given YZ. Well, YZ is going to be the part that is corresponding to BC. So I basically can just create my little proportional fraction here. So we know that it's going to be YZ that is on top of BC. So it's going to be a constant proportion of 60 over 850. Now, could we actually build a proportion here and solve for this fully? Absolutely. Do I want to? Absolutely not. Because we know that from BC to AB, we basically go down. So whatever XY is going to be, because again, AB here, and I'll just use a little box to kind of indicate the distinction, is going to be corresponding or proportional to XY. So we know that from 850 to 170, we've had a decrease. We'll just indicate that with a minus sign. So from 60 to whatever XY is also has to go down. I don't need to solve for this. So 204 is above 60. 182 is above 60. 60 is equal to 60. So our correct answer is 12. Can we draw out the full proportion? Yes. Do I want to? Absolutely not. Again, the exam is constantly kind of on a macro level in the math section, trying to get you to do things as efficiently as possible, not just the one technical way. So moving on to the next question, we've got another problem where we can be maximally efficient as opposed to fully calculating. So we see we are being asked for the value of n. And I will admit that you're probably going to need to write this out to recognize what's happening. So we are being asked for what n is. We always want to note what we're being asked for first. So n is what we're being tasked to solve for. Box that off so I don't lose sight of it. And I see that x over y is equal to 4. So I'm going to just write that up here. X divided by y is equal to 4. Simple enough. Then we've got this structure of 24 times x over n times y. I want to break this out so that I can see what's happening. I've got 24 divided by n times x divided by y is equal to 4. Because this is going to allow me to see the parts, kind of the forest through the trees or the trees through the forest, depending on how you want to, employ that analogy. Now I know what x over y is. I know it's 4. So I know that 24 over n times 4 is going to be equal to 4. Oh, easy enough. Okay. I also should recognize that for any equation on the digital SAT where there's a fraction, I want to get rid of the fraction first algebraically. So I'm going to just multiply this now kind of piece by piece equation by n to isolate the n or get the n out of the denominator. So that means I've got 24, and I'm not going to process the 24 times 4. That's another mistake that folks make all the time. Just leave it as the factors. So 24 times 4 is now equal to 4 times n. Oh, 4's cancel out. 24 is equal to n, and I avoid so much unnecessary work by just leaving everything as the pieces and not like trying to solve for x in terms of y and like plug in different values. There's a much better and efficient way to work through this. Pull up the keypad, put in my 24, close that keypad, and we hit next from that problem. So then Just clearing out the scratch paper that we theoretically would have. Looking at number 11, we're going to skip to the end, figure out what we're being asked for, and it says, according to the model, what is the predicted volume in milliliters draining from the container each second? Okay, this is where they're asking us to understand algebra at a theoretical level, not to just start calculating. And you could theoretically start modeling and doing a whole bunch of extra work, but we've been talking about throughout this video so far, I want to avoid the extra work. So question has this function W that models the volume of liquid in milliliters in a container t seconds after it begins draining from a hole at the bottom. According to the model, what is the predicted volume in milliliters draining from the container each second? Well, t is the number of seconds. So each second, 4 goes down. There's our answer. And I don't have to actually model this. You need to think about it holistically. Obviously, 300 is the starting amount. 296 is going to be what we'd have if t was 1 second, after 1 second. I'm not really sure where we'd get a 75. That's just dividing 300 by 4. But again, think about this. Don't immediately begin calculating, and you'll get the correct answer of D pretty immediately. Then we've got another graphic, and we just skip to the end, and we figure out that we're being asked for how many values of x does the function of x equal 0. So you can trust all coordinate geometry figures on the digital SAT as drawn to scale. I do not want to redraw it. It's completely unnecessary. So we've got the graph, y equals f of x is shown, and we've got the actual definition of it. And a, b, c, and d are constants. I don't want to overcomplicate this. Where the f of x is equal to 0 is just where our y value is equal to 0. Well, it happens here, it happens here, and it happens here. That's 3 times. Don't overcomplicate this. The analogy I always like to use is, if you hear hooves off in the distance, you can think about what kind of animal it might be. It could be a horse, right? That seems reasonable. That's like the kind of animal that you might hear in a lot of different places if you've got a pasture, maybe even a cow of some sort. But of course, it could be a zebra. And unless you're in Africa, it's probably not a zebra, but it could be. Assume these questions are simple horses or cows of problems. Don't turn them into zebras until they prove to have some nuanced stripes. But we'll click next from number 12 now. And again, we've got another interpretation of the algebra, not actually solving for the algebra kind of question. We've got this function of x that says 3,000 times 0.75 to the x power is going to be the estimate of the species population x years after 2008, where x is less than or equal to 8. Okay, so the 3,000, because if x is equal to 0 years, well, then 0.75 is raised to the 0 power. Anything raised to the 0 power is just 1. So at 0 years, we have 3,000 of whatever this certain species is. So we should have that mental idea before we go to the answer choices. It is certainly not the percent decrease in the population. That is going to be 25% from 0.75. The estimated percent decrease in the population for this species in area each year after 2008. Well, no, I mean, again, like that's just not the percent decrease. That was 25%. And then the estimated population for this species and area 8 years after 2008. No, it's not 8 years after. It's the estimated initial population for this species and area in 2008. And once again, I'm not engaging the scratch paper. I'm just dealing with it in the interface, and I didn't even need to pull out the calculator to do anything like that here. So we'll go ahead and hit next at this point. Now, for this problem, this is where if you actually go and look up the explanation of this problem, it is, a relatively, I don't want to say difficult quadratic. It's not the easiest of quadratics, but I don't want to do this as a quadratic. I have absolutely no need to, because if I were to just pull up the calculator here, so if I get the calculator to actually show up, there it is. What I want to do is just plug in that equation into my Desmos calculator. I've got x squared, and I got to make sure I get out of the exponent minus 14x plus 22. And then I've got these zoom out buttons. So there's my zoom out, and I can see that the minimum value of y is when x is 7. Don't overcomplicate this. I'm just going to put 7 right here. And I can actually find the relatively annoying quadratic solutions here and then find the average of them, but I don't want to do that. I don't need to do that at all. I just plug this thing in and I can see that the right answer is 7 immediately. Use the tools at your disposal. That is the Desmos calculator or potentially your own personal graphing calculator. Make sure that it follows whatever the requirements are at the time of your exam. Should be most graphing calculators are acceptable as long as they don't have like a QWERTY style keyboard, but there's absolutely no reason to do anything except plug this in the calculator, discover the answer is 7, and hit next. Now, this next question, we are being asked about what is the value of k. And we learn that the value of k is what the area of square A is k times the area of square B. Again, this is an exam that has a timing aspect to it, so you don't want to just draw this as your default position. I should know what the formula is for finding the area of a square. So square A, and I mean I already know this, is 166 times the side lengths of square B. Well, that just means that square B, we'll just call it side length B, and then that's going to be B squared. Well, when we square 166 times B, well, we're just squaring 166. So we're going to have 166 squared. There's my answer. Can pull up the keypad if I'm so inclined to 7556. But if you don't recognize the algebraic approach, we can potentially model this. And so for the first time, we'll talk about how a model might look. So on your scratch pad, you can set up k equals question mark. And we know right now that square A has side lengths that are 166 times the side lengths of square B. So B is going to be the side, and we'll just use the little square symbol of square B. And that means that the side of square A is equal to 166 times B. So that means that the area of square B using the variable of B is just B squared, because the area formula for a square, hence why anything raised to the second power is actually called squared, if you think about it that way, is just B squared. But then the area of square A is going to be that 166 times B, but we've got to square both parts. We already just did. The 166 squared is 27556. Don't need to spend more time on this question. But even if you need to write out these algebraic structures here, you probably don't want to draw it. It's just not necessary. Everything's really tied to the algebra with this geometry problem. And that's the case for a lot of geometry problems on the digital SAT. It's really more a vehicle for algebra. But we can then click next after hitting the correct answer into that problem. So then, moving on, we've got a question asking for the value of B. Now, when you have a system of equations, I need to think about elimination, not substitution. Substitution is going to be the long way, and I would say that because it's not just simple numbers, we're probably going to want to engage with our scratch work. So I'm going to write 2a plus 8b is equal to 198, and 2a plus 4b is equal to 98. Again, substitution is the long way. I don't want to get a in terms of b and then plug it back in. I should recognize that if I were to just subtract these two equations from each other, the 2a's go away. Of course, if I've got 8 of whatever b is, subtracting 4 of whatever b is, we're going to have 4b left, and then 198 minus 98 is 100. We will then divide the whole equation by 4 and discover our answer of b is equal to 25. And it really does come down to this idea that if you are being asked to solve for an equal, or solve for one variable with an equal number of equations as variables, you can pretty much bet that a system of equations is going to be the best way to solve as opposed to substitution. So moving on to the next question here. So once more, we go and look at what we're being asked for. First, we're being asked for the y-intercept of the graph in the coordinate plane. So we need to recognize that the y-intercept is when the x value is equal to 0. If you're comfortable with the calculator, you probably don't even have to write this out on your scratch pad, because we know that x is going to be equal to 0. So x being equal to 0, 2 to the 0 power just becomes 1. which means we've got negative 8 times 1, which is negative 8, which means that then we're going to just have 22 minus 8 as our y-intercept. So 14, our correct answer is A. I could write this out, but I don't think you really need to. And again, I think that anybody who's aiming for the harder second module, remembering that the modules in the math section, like the modules in the reading and writing section, are adaptive. If you're aiming for the harder module, you probably just want to keep this in the Desmos calculator to expedite evaluation. And then we'll move on to the next question. Again, just want to make sure I didn't skip anything. Here we've got we're being asked for which equation represents this relationship. So we're going to read from the top. Two variables x and y are related such that for each increase of 1 in the value of x, the value of y increases by a factor of 4, and when x is equal to 0, y is equal to 200. Okay, so this question certainly lends itself to a couple of different approaches. First, I should hopefully be able to technically understand what this is saying in terms of increasing by a factor of 4. What that means is that you multiply by a factor of 4 each time that x goes up. So if I recognize that, we should probably be able to get to the right answer immediately, and that's going to be choice D, because you're just going to multiply by 4 for each increase in x. But let's say you don't see that. That's absolutely fine. We're just going to, undo that so we can leave the answer choices open. I can just kind of model this, and the model that we can start with is what they've given us. It says x is equal to 0, y is supposed to be equal to 200. So for choice A here, we know that if x is equal to 0, then I've got 4 times 0 to the 200th. And I know that that's supposed to be equal to 200. And I go 0 to the 200 is 0. Anything times 0 is not 200, it's 0. So that allows me to eliminate choice A through the model. Then we go to choice B, and we've got 4 times 200 to the 0 power. Well, that's going to be equal to 4 times 1, and it was supposed to be equal to 200, and 4 times 1 is 4. So that's not 200. We can eliminate choice B for that reason. Next, we've got choice C, where we've got 200 again times 0, and that's going to be raised to the 4th power. Well, now we've got 0 to the 4th. 0 to the any power is going to remain 0, so this is going to go back to 0. That's not what we want, so we can eliminate choice C. And again, just proving out choice D, if we've got 200 times 4 to the 0 power, well, the 0 power just makes 4 1. 200 times 1, of course, is 200. And we can see through the model that choice D is the correct answer. Again, if you know the technical solution, go ahead and do the technical solution. If you don't know the technical solution, don't assume that you're completely at a loss for how to work through this problem. You can do it with a nice model. And again, flexibility and approach is the skill that is most valued on this exam. It's going to allow you to be as efficient as possible and as accurate as possible on these questions when maybe you just don't see the technical solution immediately. Next, number 19. So this question is another instance where if you are not certain of what the correct answer is, you're going to be able to use the calculator. So if I come over here, we can hit functions, and we hit sign, and we're going to put in parentheses 42, and we're going to get our, there is, oops, where'd it go? 42, and I need my pi button, which is right here, and I see it's equal to 0. Okay, there's our answer using the calculator, or we don't need to do anything else. I'll shrink that back down. Didn't want to do that. So there's our answer. If you need the technical solution, it's because the sign of 2 pi is 0. If you know the unit circle, it goes all the way back around. And 42 pi is just going to be a multiple of 2 pi, so that's going to be the same 0 value. You don't get extra points for showing your work on the digital SAT. You don't. Use the calculator. It's absolutely fine. You'll see their explanations are way more complex. You don't need to use it. So there's our correct answer, and we move on to the next problem. And here we once again have a question that is going to require an understanding of algebra, not necessarily processing algebra. So we're being asked to find the value of h if the system has no solution. So we need to think about what that means first. So for a system of equations to have no solution, you've got to have one thing equal two different things. And what that means is you basically have parallel lines in the coordinate plane. So I need to understand that conceptually. So if we understand that conceptually, we need to make sure that we can get our hy and our y's in the top equation to basically be equal to something similar. So we've got this first equation of 4x minus 9y equals 9y plus 5. So I want to get just my y by itself because that's how the second equation is set up. So we're going to add 9y to both sides. We're going to subtract 5 from both sides. And now we've got 4x minus 5 is equal to 18y. And we know, and I'm going to just rearrange my equations here so that it looks consistent on the scratch pad. Hy is equal to 2, well, I'll actually rearrange this even with the 4x first, 4x plus 2. So now we basically have two lines in the coordinate plane, theoretically. And I should recognize that at this point, if h is equal to the exact same coefficient of y, of 18, then there are no solutions for x. This one is probably not going to be the best kind of question to model, and the reason for that is you're probably going to have to break things down in that model too much, and it has too many variables. If they're not hiding the algebra, generally you want to attempt the technical approach first. We're going to see that again with the next couple of problems as well. But here we should be able to recognize if h is 18, there are no solutions for x, and our correct answer, of course, is that 18. So now we'll move on to the next problem. So this is one of my favorite problems in this whole section because there are a couple of ways to approach this. And I'm going to do what we'll call the easy solution first. So what I want to do, realize I got the calculator. So do the x squared minus 2x thing, minus 9. There's my solution. And there's the graph of this equation. We're being asked for the value of k, knowing that one of the equations can be written as 1 plus the square root of k. Okay, so that means that whatever this dot here is has to be equal to 1 plus the square root of k. So I'm going to just come over to my... So I know that that was 4.16228. So I'm going to just come over here, write it down for ease of reference. We know that, oh, I forgot already, 4.16228 is equal to 1 plus the square root of k. Okay, so now minus 1, we've got 3.16228 is equal to the square root of k. Okay, so I don't really know what the square roots of these non-perfect squares are, but I've got the tool over here, this calculator, and I've got a square root button, so I'm going to try 8. So if I square root 8, whoops, I forgot it's got to go the other direction, so you got to put the square root first, and then the 8, I got 2.82. Nope. So then let's try the next option, square root of 10. Oh, hey, 3.162277, that's going to round up to 8. There's my answer. This is your kind of clumsy, let me just, for lack of better phrasing, brute force it solution. It's absolutely fine to do this. There's no checking of your work. If you can recognize that I can use the calculator, use the tool at your discretion. Also, you might have been able to figure out that this square root of k in this structure here is going to be greater than the square root of 9, because that would be 3, but it's going to be less than the square root of 16, because that's going to be 4. So C and D are out, too. So look for those logical evaluation opportunities. I may not have even needed to plug this into the calculator. There are so many ways to work through these problems. Now, the technical solution, we should go ahead and see it. I mean, there's nothing wrong with seeing the technical solution. We've got x squared minus 2x minus 9 is equal to 0. And you may recall something called completing the square. So I'm going to add 9 to both sides. We've got x squared minus 2x is now equal to 9, but that's not a perfect square. So I'm going to have to add 1 to make this into a square. So now I've got x squared, or sorry, we've got x squared minus 2x plus 1 already there. And we know that that can be rewritten as minus 1 squared. And if you were to actually refoil this out, x times x is x squared, x times minus 1 is minus x times minus 1 is minus 2x, minus 1 times minus 1 is positive 1. So we've got x minus 1 squared is equal to positive 10. We're going to have to square root this on both sides. And so now we know that it's basically plus or minus, it's going to be that plus or minus 10 thing. I don't really need to do all of the work here though, and that's going to be enough. So I just end up by that square root, x plus 1 is going to be my square root, or sorry, x minus 1 is going to be over here, and we've got the square root of 10, well, plus or minus 1. If you just move around the 1 with the x, and so there's my square root of 10. Does not need to be done though, because we could have used the calculator to brute force this. Then we've got our final question of this section, and here again, we've got to think logically first. So with this style of problem, I again don't really want to model. There's not a great alternative solution directly, but I should be able to recognize some things immediately. So if we have choice A be the right answer, we can kind of plug that in, and we'll do this just on the right. So we're looking for which of the following is a solution to the given equation. So we'll just take a look at the very highest level of these answer choices. So the part that's going to make it weird is the square root in the denominators, right? So if negative c is our value, well, then we've got negative c squared minus c squared under a square root symbol as a denominator. Well, if I've got negative c squared, that's going to become just positive c squared. If I've got c squared minus c squared, that's going to be 0. Square root of 0 is 0. I can't divide by 0. That's going to create a non-real solution, so goodbye choice A. Guaranteed 100% wrong. Similarly, if I look at choice B, I go, well, I need the square root stuff, right? Like if I just plugged in negative c squared minus 39 squared, the square root is immediately kind of ignored. So I do want to give myself the opportunity for a logical evaluation if I'm not absolutely certain of how to work through a technical solution. So this is probably, for most folks, the hardest question in this section. And it is true that generally the difficulty level of problems in the digital SAT increases throughout the section. So you kind of assume the earlier ones are easier, later ones are harder. But let's take a look at how we can distinguish between choices C and D and get to the right answer. So now that we've considered how to eliminate choices A and B, looking at choices C and D, we've got to figure out how to isolate for our x. And the way that the equations are set up, we can see that 39 is the only constant itself that is known. We know that c squared is a positive constant, but we don't know what c is. It's an unknown. So if we were to maneuver that c squared over to the left-hand side, we'd end up with x squared minus c squared is all over the square root of x squared minus c squared. And that's going to be equal to 39 because we have the exact same denominator for both x squared and c squared. So we can just combine the numerator as x squared minus c squared. Now that we've done this, we can then multiply. I'm going to zoom out just a little bit to give me a little bit more room. Our 39 to get the x squared minus c squared out of the denominator. So we're going to multiply by x squared minus c squared. And we've got x squared minus c squared is equal to 39 times the square root of x squared minus c squared. Now, what's going to happen is we're going to have to actually square everything. Now, when I do this, I don't want to expand. I'm going to just leave it as x squared minus c squared times x squared minus c squared on the left-hand side. And then on the right-hand side, we now have 39 squared times x squared minus c squared. And at this point, we recognize we can cancel out the x squareds minus c squareds. So x squared minus c squared is now equal to 39 squared. We're going to add c squared back to the other side to isolate for the x squared. So x squared is going to be equal to 39 squared plus c squared. We're going to then square root the whole thing. And we get that x is equal to the positive or negative square root of 39 squared plus c squared. And of course, we don't have the positive option, but c, it's not 39 squared minus c squared, it's 39 squared plus c squared. Doesn't matter which order it's done in. And our correct answer is the negative because that's the only option that was given. So that's how you solve what is probably for most folks the most difficult question on the exam, but we were able to get it down to a 50-50 shot just by considering the logical implications of A and B up front. To solve for it fully, you're probably going to have to do that manipulation. The manipulation is a little bit difficult, but you just go very deliberately and you can reach the correct solution. Now, when we hit next once more, we can close out the calculator and you'll see the review screen. You can go back to any of the questions that you would like to review before the section timer ends.